Okay, so in this video it's very similar to what we just did, but in this particular video, instead of having the focus, we're actually given the directrix. So again, I'm just going to flip back through my student notes that you're given in your paper and look at what it says about the directrix for parabolas. Okay, so we're doing problem 1 first. So in problem 1, we're told that the directrix is y equals 2. So I'm going to flip back to where it was talking about parabolas. I know the vertex is at 0, 0, and see where is the directrix y equals. So I had a rule that says y equals negative p, and if it was y equals negative p for my directrix, then the parabola opens up and down. And the focus was at 0p, and the actual parabola itself had an equation of x squared equals 4py. What we need to do is figure out what p is. Well, based on the pattern, obviously y matches up with y, so that means negative p is equal to 2. Well, I don't want negative p, I want positive p, so I've got to get rid of this negative. So what that really means, I have a negative 1 in front, get rid of negative 1 by dividing by negative 1. So p equals 2 divided by negative 1 is negative 2. So now, using that information, now that I know what p is, I can plug in and find where the focus is and what the actual equation of the parabola is. So the focus is now at 0, negative 2. And my parabola equation becomes x squared equals 4 times negative 2 times y. I want to clean this up as much as possible. So x squared equals negative 8y. And I want to get y by itself so I can graph this. So divide by negative 8, divide by negative 8 on both sides. So I have x squared over negative 8 equals y. My calculator can graph this, no problem. So that's the equation that I was looking for. And if I graph this, we are in fact going to see that this parabola opens up and down. My directrix, if you graphed it, is going to be horizontal, which means the axis of symmetry is vertical. And my focus is going to be on the inside of my parabola. What I would recommend you do now is pause this and get as much information down as you need. Maybe try to work this out, or a similar example, work it out on your own. When we come back, this information is going to be gone. We're going to do the second problem on here. Alright, so we're looking at the second problem now. So again, we're given the directrix. So I'm going to look back at my student notes where it talks about the directrix. And I'm looking for when the directrix is x equals something. So in my notes it says x equals negative p. If the directrix has that format, then I know that my parabola opens left and right. I know my focus has the point p, 0, and the parabola itself has an equation of y squared equals 4px. What I need to figure out is what is p? Well, based on this rule from our notes, x goes with x, so that means negative p has to be equal to 3/4. Well, I want p, not negative p, so I've got to get rid of the negative. So I'm going to pretend that there's a negative 1 in front of p and divide by negative 1 to get rid of it. Well, a positive divided by a negative is just a negative, so p is equal to negative 3/4. Now, using that information, I can find out what the focus is and what the equation of my parabola has to be. So my focus is at now negative 3/4, 0. And plugging in for p, my equation of the parabola becomes y squared equals 4 times negative 3/4 x. Cleaning this up as much as possible. If you need to use calculator here, go ahead and use that calculator. But I have y squared equals negative 3x. But again, my calculator cannot graph y squared. So like we did in the previous video, we're going to have to split this up using square roots. Since my power is even, I have to include the plus or minus. So y equals plus or minus the square root of negative 3x. Now, your calculator does not have a plus or minus button like we discussed in the previous videos. So to graph this, you're going to have to split this up into two separate graphs. So I'm going to say y1 is equal to the positive square root of negative 3x, and y2 is equal to the negative square root of negative 3x. These two graphs combined will generate that graph. And what you'll see is that this parabola opens to the left and right, and that means the axis of symmetry is horizontal. And that also means that our directrix, if you graph that, is vertical. So, and our focus is always on the inside of the parabola. That's it for this video. Let me know if you got questions.